And welcome everybody to the Daily Space Weather. Lots of stuff going on. Coronal hole wind stream about to arrive. Only one sunspot. Coronal holes dominating the Earth-facing portion of the solar disk and a major active region rising. This and lots more to talk about on today's Daily Space Weather video. Also, we are relaxing our coronal mass ejection watch, as we've seen some filamentary collapse and some integration into solar wind. Also be talking geomagnetism a little bit. Here at the Smash News Network, least busted name in news. This is from the SDO, by the way, the Solar Dynamics Observatory. For your new viewers, this is 171 angstroms, ionized iron. And let's take a look at some more imagery here of the closest star. Here's sunspot 2851. Which is looking pretty weak here. I think it is still beta class. We'll show an analysis of the fields at the end of the video. This is a composite wavelength, by the way. This is ionized helium and iron, 211 angstroms and 304 angstroms composite view. And sunspot 2851 is this bright region right here. The main feature to be watching right now is this rising region. It's looking huge. It's at quite a high latitude, meaning it's pretty close to the pole. Or you could say it's far from the equator. More imagery of that at the end of the video. And here's a star chart for all of you astrology types or astrographers, perhaps. Some stories in the news today about, not Rigel. Some stories in the news today about Betelgeuse. We'll get to it on today's cosmology segment, which will be a separate video today. If you're up before dawn, you may see Saturn, Jupiter, and the Moon out there on the ecliptic, which is this yellow line, the path the sun will take across the sky. Here's a diagram of the solar system. If you're wondering where stuff is, Earth is about to move past Jupiter. And there's where things will be in a week as we approach the Jupiter opposition. Or is it a conjunction? I can never remember which is which. Here's the 10.7 centimeter radio flux animation that we've created. Yes, the upper chromosphere and lower corona of the closest star have been known to produce radio emissions. So this low region right around here is emitting a radio signal in the 10.7 centimeter radio flux variety. The radio flux now at only 74, a little bit higher than yesterday. Still hardly above solar minimum conditions. Look for this to suddenly ramp up, especially with that large active region rising. I think that's why it's already come up. I don't think it's from sunspot 2851. Here's the Space Weather Enthusiast dashboard, and they've moved back, well, we should move back the expectation for geomagnetic unrest. As the coronal hole wind stream is just arriving, we've got an increase in the solar wind density, awaiting the drop in the solar wind density, and an increase in the solar wind velocity. Still very low velocity. We'll get to it in a minute. First, global seismicity. It looks like Volcano Discovery's 90-day chart is down. They're probably in the process of refreshing it. So a bit of a lull in earthquake activity here, although some deep quakes like this 5.3 at Fiji at over 539 kilometers depth. 539 kilometers depth there on that 5.3 magnitude quake in northeastern Oceania. So we've got some 5 magnitude quakes here, nothing over a 5 magnitude. So nothing in the 6 range. There's a deep quake in the Bande Sea at a 5.1, 117 kilometers depth for that. And we're just going to scroll the list here. We don't want the video to be too long, as this is a recorded video and we want to get the daily space weather out to our viewers. Here's a 5.3 at Taiwan as well. So a bit of a lull in earthquakes there over the past 24. Let's check volcanoes. Suminoseijima's erupting. Flight level 060 as it produces a 6,000-foot plume of volcanic ash. Merapi on central Java, 14,000-foot ash plume as it explodes. Pavlov, so quite a bit of activity in the Aleutian Islands actually right now. and indeed the Alaskan Peninsula, Pavlov. Because of seismic and infrasound data, aviation code raised to orange. It's a volcanic eruption watch from Pavlov on the Alaskan Peninsula. Sangay producing a 19,000-foot ash plume over Ecuador as it explodes. Revenador exploding as well over that same nation, Ecuador. 15,000-foot ash plume from Revenador. Sabancaya, intermittent emissions of volcanic ash and explosive activity have produced a 24,000-foot ash plume over Peru, and we're not able to determine whether or not Nevados de Chilean is erupting in central Chile. Probably because of cloudy days, the satellite imagery is not letting us know. But I'm letting you know that you should certainly not pole vault the caldera. It could be unhealthful. We need the views on YouTube. So tell your friends and foes about the channel. Maybe pick up some merch. Head to smashamash.org, which will redirect you to our homepage at smashamash.com. This public service message brought to you by Smash Staff and I, who would prefer for you to be safe and prepared for reality in this public service message. Next, looking at the X-ray data here, solar flares. No major flares, although we're getting into a B range here, output. Pretty sure that active region is going to be a sunspot. We'll keep you posted. We'll probably make another video later this afternoon about it, especially if we see a massive umbra rise, as the likelihood of major solar flares is higher at the limbs. Here's the GOES proton flux over the past 3 days. No spikes there. No coronal mass ejections headed our way. Coronal mass ejection watch has been relaxed. GOES magnetometer over the past 3 days. There's the data from that, also measured by the GOES 16. Some spikes here as the coronal hole high-speed wind stream arrives. There's plasma in between Earth and Sun in the form of a coronal hole wind stream, and it's just arriving. Let's take a look at the current sheet. Before we get to stuff like the solar wind data. So here's the heliospheric current sheet. This is part of the National Sunspot Observatory data. And there is a North Pole current sheet, which is going to be delayed, by the way. Earth is going to remain in the South Pole current sheet for the foreseeable future. The South Pole current sheet shown here in red, North Pole shown here in green. And here's a line-of-sight view of the same data. It's from 51 ground-based magnetometers, the National Sunspot Observatory, that is, and magnetometers on stereo A and stereo B. Here's the coronal hole line-of-sight plot, and you can see some significant South Pole-oriented coronal holes rotating through. Surprisingly, no trans-equatorial coronal holes. Also another one showing up here ahead of this active region, North Pole-oriented there. Leave us a comment if you think coronal holes and sunspots are related or if it's just a coincidence the way they appear. I've got a theory on it. I won't share it in this video. We'll have to save that for a later content. And here's our flare monitor, our flare watch, our automated flare watch, as well as automated detected sunspot group system. Pretty sure sunspot 2850 has already degraded. Sunspot 2851, which is, I believe it's this one here, again, looking pretty weak. And this one we reported on yesterday, had 3 umbrae. Now it looks like it has 0 umbrae. I don't think it existed long enough to get a name. Global geomagnetism currently at a KP of 1. And the planetary K index, we call it the KP index, whatever you want to call it. For you new viewers, that's the global geomagnetic measurement. And looking at the real-time solar wind, you can see this uptick here in the solar wind density, coming up from about 10 protons per cubic centimeter, just about doubling till the current time. Now at about 20 protons per cubic centimeter. Solar wind speed still quite low here, 309 kilometers per second. So we're going to see a major spike here in the solar wind speed from that coronal hole wind stream we're expecting. And the likelihood of that is 70+%. You can expect to see the solar wind density drop off and the solar wind speed come up. Current solar wind only 307 kilometers per second. Also of note, the BZ in the top pane, the red line up there, has recently shifted into negative territory, which increases the geoaffectivity of incoming solar wind. Next, the Geospace Magnetosphere movie, they're back. Here's 4 hours of data for you showing magnetohydrodynamic pressure in nanopascals. It's modeled by the space weather modeling framework, and it gives us insight into the location of things like the geomagnetic poles. Anyway, fairly homogeneous pressure here over the past 4 hours. Here are ground magnetic perturbations. This gives you insight into the Earth's magnetic poles, as well as the geomagnetic poles. This is ground magnetic perturbations, changes to Earth's own B field measured in, well, modeled in nanotesla. So that's 4 hours of data also. And we can expect to see an uptick on both of those when the solar wind velocity suddenly increases. So thanks everybody. Seriously, thanks very much for realizing the existence of our channel. It was not easy to get where we currently are, and we ain't going nowhere besides straight to space. So thanks again to all of you viewers. And we've got a 2,000 subscriber special, a YouTube exclusive coming up. If you've got ideas for what to do for that, let us know. If you haven't seen our video entitled Geomagnetic Mayhem, Eugene and Smash Square Off. Who's the geomagnetic jerk? Go check that video out. You can find it in our playlists. youtube.com/smashamash/playlists. And make sure you subscribe to Eugene the Philosopher. If you haven't, shout out to Eugene. Hopefully you're not yet in a gulag. We also do regularly stream live to Twitch, and let's do a demo integrated into today's daily space weather video. So we've actually started a live stream here. And welcome to our Twitch viewers. Welcome, Twitch viewers. We've decided to stream live momentarily just to let you know that today's daily space weather video will not be appearing on Twitch. So make sure you subscribe over at youtube.com/smashamash. If you're only viewing the videos on Twitch, you're missing like 80–90% of the content. Twitch.tv/smashamash is where this portion of this video was initially streamed. They've got a great mobile app, twitch.tv/smashamash. Twitch is, I think, the ultimate live streaming platform. We're also on BitChute, and if you're viewing the videos over there, make sure you subscribe on YouTube. Again, you're missing 80–90% of the content. YouTube is the most feature-rich platform that we use, and that's why we use it the most. We just strive to follow the rules over there. We don't want to get banned or demonetized or anything like that. We prefer for our content to show up on your screens. So let's end the Twitch stream by Twitch, and we'll be streaming live with you soon. Again, check out youtube.com/smashamash. Lots of content you're missing if you're only viewing on Twitch or on BitChute. Today's cosmology segment will be a separate video, so make sure you catch that later in the day. It should be fascinating. More great stories coming out today for us to cover. Next, moving into the realm of electron flux. To see no charging hazards. Right now, electrons have the capacity to charge up satellites. It's not currently occurring. Here's the electron flux over the past year as reported by Solon.info. And we're just in moderate levels, although they've actually fallen off a cliff here as we forecasted. So the coronal hole wind stream showing up here in terms of the density wave on the shock front. We did recently get into warning territory once again yesterday. Those levels coincide with 1,000 pulse flux units. That's the GOES electron flux over the past 3 days. And we can expect this to crater as we see the solar wind velocity rise with the arrival of the high-speed portion of the coronal hole wind stream. Next, relativistic electrons in forecast form. And I would tend to agree here. I would just say these are going to be a little bit lower. That would be my forecast. That little purple dot I just put there, we're expecting levels a little bit lower than the NOAA forecast, which is the green box. The yellow diamonds are the observation. Here's a diagram of the atmosphere. Feel free to pause the video if you want to know about the Van Allen belts and distances to things like the SDO and the Van Allen probes and the International Space Station, actually. And here's the total electron content showing you electron density for the entire air column through both Van Allen belts. And we see fairly coherent blobs of electrons here. This is looking quite normal, looking quite non-anomalous. And what we mean by non-anomalous is that most of your GPS errors will be occurring around the equator around noontime. So a fairly coherent and organized set of electron bands right now. Here's a diagram of the atmosphere because we're going to be showing you the F ionosphere layer next. Located at about 300 kilometers of altitude, this is just one slice of the atmosphere showing you vibrational frequency in megahertz, millions of vibrations per second. And we've been citing some anomalies here, especially around the South Atlantic anomaly. No real surprise there. It's the weakest point in the Earth's magnetosphere. The South Atlantic anomaly now over the South American continent, right about where that X is. There's also another weak spot down here. Not quite as significant. We'll call it the South African anomaly. Things actually not looking that abnormal right now. Here's the latest image from 10:15 Universal Time, and here's the anomaly map. So this is the megahertz-based anomaly map for the 30-day median. And as we move closer and closer to the autumnal equinox, or the vernal equinox if you're in the southern hemisphere, shout out to our southern hemisphere viewers. As we approach the equinox, we get more geoaffectivity and the likelihood of more anomalies as a result of that. Obviously, the ionosphere is the bridge between Earth and space. And let's bring up the latest image here. You'll see it's not very anomalous at all at the moment. 10:15 Universal Time looking pretty normal there. We will do a meteorology segment today. That will also be a separate video here at the Smash News Network, Least Busted Name and News, so make sure you check that out. We've got playlists for our meteorology and our cosmology segments. We do those regularly. Here come bonus features. So here's the latest hydrogen alpha imagery from the ground-based observatory at El Teide, Spain. Quite a bit of filaments there around the western limb. You can see all those flamin'-looking filaments there overlapping. Those are all what we call prominences. When we see plasma filaments overlapping the edge of the solar disk. Great imagery there of the lower corona. Here's the GOES 16 SUVI imagery. And you can see a little bit less filaments. We still could indeed see coronal mass ejections. We're just relaxing the watch now. There's not that much plasma. And for you new viewers, we only forecast coronal mass ejections on the Earth-facing side of the sun and around the poles. Here comes some high-res imagery. But first, thanks to our patrons, the true source of funding for this content. Please consider becoming a patron and helping us out, increasing the probability these videos will continue to exist, remain publicly visible, and free for all to view. Patreon.com/smashamash if you want all kinds of behind-the-scenes information, early alerts, astrophysics stuff, and so on. Patreon.com/smashamash. Also visit our own website, check out our SMASho merch link, become a patron, buy some merch, and give Smash staff a raise. She desperately needs it. Here is the solar intensity gram and the colorized magnetogram, the latest refreshes. And let's check sunspot 2851, looking weak. Practically an alpha class sunspot, if not already. 2850 is already gone. So we're barely at one sunspot right now, folks. Here are the magnetic fields from sunspot 2851. Indeed, looking like it's weakening. Here's the first glimpse of this active region. And we don't see any umbrae up there, by the way. There is the intensity gram. There's the magnetogram. You can see no umbrae. And we'll close out the video with some composites. Once again, let us know what your favorite composite is. We're messing with some new imagery here, and we're always interested in your input. Let us know what you think of this set of wavelengths. This is 335 and 171 angstroms from the Solar Dynamics Observatory. These are both ionized iron spectra. I think that's a pretty good one. It shows a lot of variation. And here's one of the other composites that we just brought up today. Actually, this is ionized helium and iron, 304 and 211 angstroms. I think this is a very good one also. This shows you filaments as well as coronal holes, and you can see this pretty significant series of coronal holes down here in the southern hemisphere. And last but not least, all eyes on this active region in 171 angstroms. And thanks everybody once again for tuning in to the Daily Space Weather. Congratulations on realizing the existence of our channel. Tell your friends and foes, press share on social media, and may that solar wind be at your back.